Welcome to Brain Vision.
All right, hello. In this question, we're told that we're pushing our physics book across a table here, and we're applying a force of 2.4 newtons, and the force of friction in the opposite way is 0.6 newtons, and we move the book a distance d of 1.5 meters. And we're asked various work questions. The first is, what is the work done by our 2.4 newton push? So the work done by our applied force. Well, we know that work is equal to force times distance times cosine of the angle between those two. So in this case, my force vector is going to the right. My distance vector is going to the right because that's the direction my book travels. So that's the direction of d there. And so the angle between those two, well, I have force there, distance there. The angle between those two is going to be 0. So cosine must be 1. So in this case, the work done by my applied force is just going to be my applied force times my distance, which will give me 3.60, and work is in joules because it's energy, so 3.60 joules of work. We're asked for part B, what is the work done by friction? Well, we're going to have the force of friction times the distance that we travel times the cosine of the angle between those two vectors. In this case, our distance vector, it's still going to the right because our book is still moving to the right, but our friction vector goes to the left. So theta in this case is going to be 180 degrees. And so we have the work is going to be our force of friction, which is 0.600 newtons, times our distance that we travel, 1.5 meters, and then times the cosine of 180, which is going to be negative 1 there. And that will give me a work of 0.900 joules, and that is negative work. We're then asked for the normal force. What is the work done by the normal force? So the work from the normal force, well, if I draw my normal force vector on here, it's always going to push up, right, against the surface. And in this case, my normal force vector is up, my distance vector is to the right, so the angle between them is 90 degrees. And we know that the cosine of 90 degrees is going to be 0. So in this case, the work done by our normal component is 0 because we're not actually traveling at all in the y direction. And the same will be true for gravity. So if I have the force of gravity here, that is still completely normal to my distance vector, right? My distance vector goes to the right. My gravity vector goes down. So the work done by force of gravity is going to be equal to 0 because I'm not traveling in that direction at all. E then asks, what is the net work done? Well, that's just going to be equal to the sum of all of the works. So that will be 3.60 joules from my applied force minus 0.900 joules from my friction, plus 0 from my normal, plus 0 from my gravity. And so I'll get a net work of positive 2.70 joules there. Hope that made sense, and I hope that helped out.